Hi, I am Yanis, and I record for monkeys to find the neural correlates of consciousness. The central conclusion at the end of this presentation is that, contrary to widely held beliefs, cells in IT contexts encode both conscious perception and also unconscious suppressed stimuli. First, some background. How can we distill neural correlates of conscious perception rigorously? In a typical task, there are at least three variables to be represented. First, a monkey views an image, which causes visual processing of the physical input, regardless of whether the monkey becomes conscious of it or not. Then, the image may evoke the conscious percept of, for example, a face. And then, the monkey may report that he saw a face. If a neuron fires during this task, how do we know it represents conscious perception rather than the other two factors? In Binocular Rivalry, you present, for example, a face to the left eye and an incompatible stimulus, for example, a taco, to the right eye. This causes your conscious perception to alternate between the two, even though physical input is fixed. So we can dissociate the physical input from conscious perception. In the 90s, Scheinberg and Logothetis trained monkeys to report the percept during Binocular Rivalry, but that still leaves the report confound. How do we know what a monkey is perceiving without him reporting it? Here we introduce a new no-report paradigm that infers this percept from eye movements. We train monkeys to follow a jumping fixation spot. However, the fixation spot is in a different position in the left and right eye. Hence, when the monkey is perceiving the taco, he will saccade the fixation spot in the left eye. When perceiving the face, he will saccade the fixation spot in the right eye. In human subjects, we can predict the button press reports from eye movements with 93% accuracy. Therefore, the need for active report is eliminated. We record from monkey face patches while monkey performed the task. Here's the response of an example face cell when we physically switch image, so there's no binocular rivalry yet. The cell responds more during the switch to face, shown in red. Now the big question is what happens during binocular rivalry when we infer from the eye movement that only the conscious percept switched to face or object. Intriguingly, the cell clearly responds more strongly to the conscious percept of a face, even when the physical input is fixed and there's no report. Here's a population analysis. Every dot is one cell, and 53% of cells in face patch ML and 73% in face patch AM are significantly and consistently modulated by the conscious percept of a face. We record not only with single electrode, but also multi-electrode arrays, such as novel primate neuropixels that we helped develop. Here are the responses of 80 simultaneously recorded cells to 96 different images. Most of them are face cells. And this is an example time course during binocular rivalry. You can see that the population responding more during red epochs, where we inferred the percept to be face from eye movements, compared to the blue epochs. We could linearly decode the conscious percept on a single trial from the population response with up to 88% accuracy in the best session. Now, do neurons exactly reflect conscious perception? We found that even on a single trial basis, modulation during rivalry was weaker and less bimodal compared to physical switches. Could this be because cells encode both conscious percept and the veridical physical stimulus? To test this hypothesis, we presented two different rivalry stimuli to vary the suppressed stimulus while keeping the conscious percept fixed. That is, the decoder had to discriminate between trials where the conscious percept was fixed as face and the suppressed stimulus was either taco or apple. Surprisingly, we were also able to decode the suppressed stimulus with 74% accuracy. Is it that one subpopulation IT encodes the conscious percept and a separate subpopulation encodes the suppressed stimulus? We found that the modulation index for the dominant consciously perceived stimulus was positively correlated with the modulation index for the suppressed stimulus. This suggests that there are not two different subpopulations, but the same cells that encode conscious perception also encode the suppressed stimulus. Let's summarize. It's a commonly held belief in the field that most cells in IT cortex respond to the conscious percept exactly as they do to the physically present stimulus. The fact that we could decode both the conscious and suppressed stimulus shows that this is not true. Instead, single cells multiplex both the conscious percept and the veridical physical stimulus, and either can be read out from the population code using two different decoders. One possibility is that a cell's average firing rate is determined by mixed selectivity to conscious percept and suppressed stimulus. In an alternative model, it could be that one type of spikes represents the conscious percept and another type of spikes represents the veridical physical stimulus. Now, if you have any questions, I would love to chat more. So feel free to come by the poster. See you there.